Welcome, welcome, welcome to strengthening your math engagement with Desmos for grades 6 through 12. Now, if you're like, hold up, I don't teach grades 6 through 12, that's okay. You're still welcome, but we're just telling you the focus is for grades 6 through 12, so don't get mad. All right, and we're talking about math engagement using Desmos. I have been introduced to Desmos before, but I'm really looking forward to getting deeper into it because I don't, once you don't use it, you lose it. So I'm looking forward to get back into my Desmos knowledge. Who am I, you may say? Well, hi, I'm Dr. Desiree Alexander, and I'm the founder of Educator Alexander Consulting. What's up, everybody? And these are all of the different ways that you can get to me. Woo woo. All right, what do we have coming up? So we have ELA Teachers 20 Best Technology Tools for grades 6 to 12. And this is a session through BER. So if you know BER, you love BER, this is a paid session. So I like to make it clear, mostly everything I do is free, but this is a paid session on October 25th, November 2nd, and November 25th. You can go to that website at alex.net/events to check it out. Then we have the TCCA conference. If you are in the Houston area, it is the biggest Texas tech conference except for like the state conference. So you definitely want to come check this out. It's one of my favorites. I'm a vendor there and a spotlight presenter. So you see all the sessions completely free and I absolutely love it. All right. Then November 4th, we have Learning Through the Metaverse. So if you're thinking about AI, what is all this AI stuff? I don't get it. I don't know. Come and learn from our resident AI presenter. Rochelle is part of the family. She's presented about 25 times for us, and she's coming back for Learning in the Metaverse. Then we have voice, value, and validation, a paradigm shift. So looking at, do our students feel valued? Do they use their voice? Are they validated? We're going to learn all about that December 2nd. And then we have Rochelle coming on back December 9th with NFTS in education. If you're like, NFT, no, it's NFTS. And you can learn more about it. Again, dealing with more AI. Learn more about it on December 9th. January 20th. So we're skipping over to next year. School library, optimizing your budget. So love, love, love. Former librarian here. Can't wait to hear about optimizing your budget, whether you have a big budget or a little budget or no budget. What can you do? Then we have, this is a brand new one, y'all. Now we're getting to the brand new things. Up your Google game. Google tips, tricks, and time savers to boost your productivity. We have Lisa and Sarah, double presenters, coming to talk about that January 27th. Then we have the TCEA conference. So this is a paid conference in Texas, one of the biggest technology conferences in the United States, except for, of course, ISTE. So yay to that. Then we have asset-based teaching, changing your perceptions to increase student achievement by Dr. Eileen. If you've never seen Dr. Eileen teach, you want to come see Dr. Eileen teach. All right. And then we have, this is another brand new one. It hasn't even been announced yet. This is the first time I'm talking about it. In-class flip, design active learning spaces for student-centered learning by Martha Ramirez. Cannot wait to see that one. Another brand new one, teaching past the test. So this one is for Texas certification test. So if that is something you're interested in or something that other people are struggling with, definitely tell them to come and check this out. AI for educators, just straight up AI for educators. So how does that work? What is AI for educators? Presented by Ken K. So we have that in March. And then the keys to successful classroom management. Now, Dr. Marlene from teaching us all about SPED. So she's done a whole bunch of SPED webinars for us. You can check them out on the YouTube channel. So she's mixing it up a little bit this time and talking about the keys to successful classroom management. So I'm looking forward to hearing her speak again and on a different topic. Whew, that was a lot. We always have our self-paced classes, always ready for you on Google certifications and educational leadership certifications, all that good stuff. You can check it out from the website. And remember to tell me what you want to learn or tell me what you want to teach. You can always do that. This link is also all on the same website at alex.net/events. All right. So now what we're going to do is get what you came here for. We're about to start learning about Desmos. I'm excited. Hopefully you're excited. And what we're going to do is get started right now.
All right, thank you. Good morning, all. Before we get started, I want to throw out a huge thank you to Dr. Desiree Alexander for hosting this webinar. I'm excited to be here with you today, and we're going to jump in and introduce you to some great things with the Desmos platform. Now, to begin with, what I'd like you to do, just to build a little bit of engagement to get started here, is I'd like to ask you to think about this question for a moment. What's an example of a sentence that you'd want your students to say about you, their math teacher, at the end of the year after completing your class? What's an example of a sentence you'd want your kids to say about you, their teacher, at the end of the year after completing their class? And to share this, I'd like you to open the chat, and in the chat is a Reflections Fig Jam. Fig Jam is it's kind of a replacement for the Google Jamboard that's on its way out soon. And so there's a link I just posted in there, Reflections Fig Jam. Click on that link, and you will see a screen that looks a lot like my shared screen right now. And I've already added one sticky note to it. So here's what we're going to do. If you don't mind, could you just add your sentence to the Zoom chat? Thank you, Lydia, for sharing that. That's weird that the icon bar doesn't show up for you, but if you could add to the chat, that'd be great. We can share our sentences this way. Okay, here we have some of these sentences coming in now in our chat. D, that's awesome. Your teacher, meaning you, helped the students understand how to write equations from word problems and solving them. That's awesome. Lydia says that she'd love her students to care about them academically and personally, and that she was good at explaining things in a way they could understand. That's awesome. All good teachers have that ability. Oh, I love that, Veronica. If you could mix in a little fun and interesting strategies in your classroom, that's going to be awesome. Your kids are lucky to have you. Kim, I love it. If we can get kids to have a little more self-confidence in themselves and believe they can do the mathematics, that's awesome. So great sentence. Thanks for sharing that. Okay, well, we're going to go ahead and move forward. Thank you for sharing those sentences, everyone. My name is Andy Malbouef, and I loved seeing those responses. Welcome to today's webinar on Desmos and creating engaging and opportunities for students. I can already tell we're going to have a great experience together. First, a little bit about myself. I taught math, high school math, up in Michigan, and I recently finished my 32nd year in the classroom. While I'm a high school teacher, in my seminars and workshops and webinars, I work with math teachers in all different grades, primarily 6 through 12, but all different grade levels. And I feel that Desmos is the single most influential piece of technology that I've seen in my lifetime to come along in support of math education. And I look forward to being here today to share some of these great ideas and strategies with you. I do want to thank you for being here today. It says a lot about you as a teacher to be attending professional development on the weekend, a time that's so badly needed for you to rest and recharge your batteries. So I applaud you for your commitment to improving your teaching. A couple of housekeeping items. If you have questions at any point, please feel free to add them to the chat. I will check it periodically. Or with the small number of people we have, please feel free to unmute yourself and just ask over the microphone. We're going to be very informal here today, so don't feel like you have to wait until the end of a session for a Q&A period. Just ask when those questions come up. And if a question is posted in the chat and you feel like you have the capability of answering it for somebody else, please go ahead and do so. I'd very much like for this to be a collaborative group as we go through our next couple of hours. And if you need to step away from this webinar for a moment or two to take a phone call, to use the restroom, etc., please be comfortable in doing so. Our focus today is going to be on Desmos. We're going to have three main parts to this. The first part is we're going to introduce the graphing calculator part of the platform. Some of you may already have some familiarity with it, but with Desmos now embedded in the digital SAT that all of our high school students are going to be taking this spring, that's going to be something that we want to have them have familiarity with. After introducing the graphing calculator, we're going to move over to the activity side of the platform, and we're going to introduce you to the engagement opportunities that an activity can have in a classroom. And finally, our last main session will be we're going to explore different teacher strategies to employ and teacher tools available that can be used by us as teachers with our students as they go through activities. A central theme throughout this webinar is on creating practical applications for you in your classrooms. We may be all coming into this webinar today with varying degrees of experience or familiarity with Desmos. Some of us may be beginners. Some of you may have used it before, and others of you may have some, significant experience with it. We have something for everyone. My goal is for all of us to walk away with something useful to implement in our classrooms. If you're a beginner, we'll show you the easiest ways to get started using the platform, the calculator part and the activity part, and you can start running activities with your students next week if you like. And those of you with some experience can grab some new ideas and strategies along the way. And with our varying degrees of experience with Desmos, I'd like you to give yourself permission to absorb what's going to be good for you and not worry about trying to master everything. So let's take a quick look here at my shared screen, in which I have kind of an outline or an agenda for the day. As I mentioned, we're going to start out by exploring the graphing calculator, and then we're going to get into the activity side of the platform, and we'll finish up about 12:50 today Central Time with something called a polygraph, in which we can get kids talking about mathematics. At the top of this screen is a link to a digital handbook. And I'm also, again, going to put this link in the chat. This is called my presentation link. So if you want to access this presentation link, you'll have access to this document and you'll be able to grab these links and use them whenever you'd like. I would suggest you make a copy of this so that if you want to make any adjustments or add anything, you have that ability to do so. But that digital handbook is available to you for as many times as you'd like to access it. And it really goes far beyond just what the 2 hours are that we're going to be exploring together here today. So I want to begin with the calculator side of the platform. So on my shared screen, I'm showing you 3 different screenshots here. These 3 different screenshots show you the different avenues that can be explored with Desmos. In the upper left here, the main part of the platform is desmos.com. And this is where they contain all of their math tools, and they also have links to other places that you can go from here. On the upper right, they have an activity side of the platform geared towards teachers. So we will also be exploring this today. You'll notice that it puts the word teacher in front of desmos.com. This is for teacher use only, and here's where we can develop, share activities, assign activities to our students, things like that. And lastly, on the bottom, the students have a side of the platform that they can access as well, in which they can sign in and they can access any activities that you, as their teacher, can assign to them. So to begin with, if you're comfortable doing so, I'd like you to, on your computer, open a new tab and go to desmos.com. Desmos.com. We're going to start here, and I'm going to move my shared screen over to this look right here. This is what you will see on my shared screen when you go to desmos.com. Now, if you don't feel like opening a new tab and having 2 different tabs open along with the Zoom call, etc., feel free to just stay on and watch my shared screen as we go through this. Now, what I'd like to invite you to do first, once you're at desmos.com, is log in if you have an account already, and if you don't have an account, sign up for one. A free account is extremely valuable. Any graphs or tasks or activities that you create, that you use, that you assign, you'll be able to access those over and over and over again, year after year. So I know we as math teachers, want to have that ability to access something again that works well for us. So you can save things here if you have this free account created. If you've already used Desmos, you probably already have an account. Please sign in. I typically sign in with Google, so that's what I'm going to do right here. I have a couple of different accounts. So I'm signing in to desmos.com. And once you sign in, you'll see your name, you'll see your first name up here in the upper right corner. So anything that you do can be saved if you wish to save it. So what we're going to do is just do a very short intro. I mean, it's going to be very short. I just want to whet your appetite for what this graphing calculator can do. So on the left side in the blue block here, I'm going to click on Graphing Calculator. And if you're familiar with this, I'm just going to ask you to be patient for a little bit as we go through it for new users, and I'm going to explore different parts of this graphing calculator. We have two main parts. On the left-hand side, we have what are called expression boxes, and on the right-hand side, we have the graph canvas. And sometimes those two go hand in hand, and sometimes not. So I'm going to start out with the left-hand side in the expression boxes. And this can be used as a regular calculator. Even though it's a graphing calculator, it also functions as a four-function and scientific calculator. So if you want to play along with this as we go, feel free to do so. I can go ahead and type in things like 3 plus 9, and as I'm typing, Desmos is instantly evaluating for us. So you can see the result of 12 down here. Now it also recognizes orders of operations. So if I put a right parentheses around after the 9, it encloses 3 plus 9, and I can do some other functions. Like, for example, I can raise this to a power. So to raise it to a power, there are two ways to do that. I have a keyboard shortcut, which is the caret key, Shift 6 on your keyboard, and I can raise this to a power of 2, and you can see that Desmos evaluates it for me. I can continue to add or subtract or whatever I'd like to do, and this evaluates in real time. Now, if you're not familiar with keyboard shortcuts, you don't need to be. Down here in the lower left, there's a little keyboard icon, and if I hover on it, it says Show Keyboard. I can open up that keyboard and have access to these other tools down here, and you can see that there's a squared function right here. I can raise numbers to other powers, etc., etc. I'm going to close this keyboard, and I'm going to go back up to where I left off with -5. I could also create fractions here. Actually, I'm going to do this in a new line. So I'm just going to click down to a new expression box. We call this box number 2 because it's numbered number 2 on the left. And I could type in something like 3 divide sign 5. When Desmos sees a divide sign, it recognizes you want that to look like a fraction, so it puts that nice vertical fraction in there for you. And we can actually do operations with fractions. So I could add here fractions that have uncommon denominators, and Desmos will evaluate. Now, it always evaluates as a decimal. That's the default. But if you would like to see that as a fraction, Desmos can accommodate you. If you don't like the 1.1 and you want to see the fraction, over here on the left in the blue, there's a little fraction in a circle, a little outline of a fraction. If you click on that, it converts the answer to an improper fraction. So that's a really nice tool for those of you working with younger students, elementary into middle school, on working with fraction operations. So this is 11/10. It will not make it a mixed number, but it will make it an improper fraction. And if you want to go back to decimal, you just click on that same circle on the left again, and it puts it back in decimal format. So that's just a really quick intro to using this graphing calculator to evaluate expressions. Now, if I wanted to get rid of or clear out what I have in there, I can certainly just click on these X's in the upper right of each expression box, and that clears that out. So I'm going to just show you some other things that will also be involving the graph part, the canvas, the visual part. Desmos will graph ordered pairs for us. So if I type in parentheses, an ordered pair, an X coordinate, comma, and a Y coordinate, Desmos will plot it over here on this canvas. So this can be clicked on, and its ordered pair shows here. So here's some visualization for students. You can also click the label box here, and it will stay on over here. So I'm going to click that off and just keep it off. I can add several ordered pairs if I separate by commas. So here I'm adding a total of 3 ordered pairs. I can click on labels if I want to see those labels, but these will show visually. Some style options available to you. Maybe you don't like the green color. You have other color options. So over here on the left, where I had my fraction bar before, now it shows a circle with a series of 4 dots in it. This is the indicator, if you will, that Desmos is plotting multiple points, or it's creating a scatter plot, if you will. I can turn that off with a quick click, and the points over here on the graph canvas disappear, even though the points are still there here on the left, and I can turn that on. It's a nice feature if you're teaching a task or a lesson in class and you don't want the kids to see it right away. You'd rather have them talk about something first and then see it. You can turn that on and off quickly. But here's where you can change colors. Instead of a quick click, hold down with your cursor. So I'm holding down right now. You can't really see me holding it down, but when I hold down on that green circle, I have what's called a style menu that pops up. And some things I can do with my style menu. I can change my points from solid points to open circles, or I can change them to little X's. Those are options for you. I'm going to go back to solid. I can change I'm going to hover here, my point size in pixels. The default is 9, but I could make it 12 and the points get a little bigger. I can make it 20 and you can see you can adjust the size of your points. You can make them smaller if you wish, and they're barely visible then. But those again are options available to you, the teacher. Below that point size, you have color options. So you can play around with, there are 6 basic colors available to you. For those of you that like to be creative and ingenious, if you want to eventually down the road learn about computation layer, you can create your own colors, which is a pretty cool deal. There's some pretty cool options available. So I'm going to make my points right now red. I can also turn on my label here if I wish to without checking the box. I'm going to turn it back off. And I can also add line segments between these points if I wish to show that. And again, the line segments have some different options. I can make thicker lines, dashed lines, dotted lines. Those are all options for you. Clickable is a feature that's going to be, it's more of an advanced feature that's not appropriate for this webinar, so I'm just going to ignore it. But what I did here is create 3 ordered pairs and have them visually plotted. Some other things that Desmos will do also besides graphing points, and we can put in equations. So for example, I typed in y equals x plus 1, just a simple linear equation with a slope of 1 and a y-intercept of 1. And as I'm typing, you can see the line get graphed instantaneously or dynamically by Desmos. And I created this line to go through those points that were already there. So there are some opportunities here for some good visualization for you to connect with your students in class the x and y values of your coordinates along with the equation of a line. And in box number 2, this symbol here in purple, this circle, it has a different shape inside. That's the symbol indicating you're graphing a line or a function. You can hold down here and again access those same style options that you had with the ordered pairs. So I'm going to just make my line green now. In addition, this will also graph functions. So for those of you that are working with students in 7th, 8th grade function work or high schools, you can add functions. So I'm going to use a pretty standard f of x here, and I want to make a quadratic function. So I'm going to make this negative x squared plus 3 so that I get a parabola being graphed opening downwards. And you can see here the parabola comes in a different color than the others, but I can again change colors whenever I want. And a nice feature with multiple graphs is Desmos will recognize key points for you. Let me illustrate what I'm talking about. This black parabola intersects the green line in a couple of different places. Those are points of intersection. I can hover there and it shows it, or I can simply click and that point will stay fixed there. Here's another intersection point. So visualization is great for kids to understand solutions for systems. This is a linear quadratic system, but we can illustrate what the two ordered pairs are that make that system true. I can also click on other key points on a graph. And when I say key points, anytime a graph intersects an x-axis or a y-axis, those are key points. So here I'm going to click on the parabolas, x-intercepts, and the parabolas, y-intercept. Those are also considered key points and can be used in your visualization. Okay, some other things, and I know we're going pretty quickly with this, but I just wanted to give you a quick overview of this graphing calculator. We can also graph inequalities. I'm going to turn off the previous three expression boxes I typed in there. So my graph canvas is clean, and I can type in inequalities. I typed in y less than 2x minus 1, and you can see that Desmos will recognize that as an inequality and graph the shaded region. You should also notice that it graphs using a dashed line. And here are key points. I say key points because those are x and y intercepts again. So you can have some discussions there with students. Now, some of you are probably asking, well, how do I get less than or equal to? Because that's the next logical step here. Watch where I put my cursor. I'm going to put my cursor right after the inequality, and then I'm going to type the equal sign. And as soon as I type equals, Desmos recognizes I want that equals to go under my inequality. So it puts it under the inequality, and over here on the graph, look, we have a solid line now. So we can do some great things with graphing systems of inequalities and talking about overlapping shaded regions, things like that. One more thing I want to show you in the expression boxes, and I'm going to turn this one off as well, is we can add tables. And tables are great, again, for kids to visualize, to put connections together, to extend patterns. To get a table, I'm going to go up here to the upper left, and I'm going to hover on this plus sign. Here's where I can add an item. So I'm going to click Add Item. And these are the different things we can add. And I'm not going to be able to have time to go through all of these, but I want to add the table. So here's a default table. It comes in with 2 columns. And I can add ordered pairs to my table, as many as I'd like, and you'll see them plotted over here. So if the student wishes to click on them, they see the x and y coordinates of those. So another nice feature to have is that ability to add a table. Okay, now the real reason I wanted to show you this Desmos graphing calculator is, for many of you, Desmos now is going to be the calculator of use if you work with students to prepare them on the PSAT or the SAT. And I would imagine down the road, the ACT is also going to use it for those of you that use that format. I'm going to clear out my expression boxes here. Now I've got several of them, so I can just click the X's, or I can go to this gear and I can edit the list of them. I can delete all from right here. So now I've basically cleared out my canvas and my expression boxes. I want to show you how to create a list of numbers, because students will want to be able to do this in order to do statistical calculations. A list of numbers starts out with a letter or a word equals something in square brackets. Let me illustrate. I'm going to use a capital L. For consistency, I usually use capital letters for my lists, and I'm using L for list. And square brackets. Right now I have a 0 element list. But if I were to I'm just making up numbers here, and let me throw in a negative as well. So I typed in a series of numbers. So Desmos tells me you've given me 9 elements. Here are some things that students can do with this list. They can type in the word mean, and Desmos recognizes mean as a key word. and they put in parentheses the list that they're going to calculate the mean for. So there's your mean. The students do not have to add up all the numbers individually and divide by 9. I mean, they can, but this is going to be a little bit quicker. They can also use median. And there's the median of list L. It does not calculate a mode. That's something that the students would just have to evaluate visually on their own. But here are some other statistical things that Desmos will do with a list. You can type in the word stats, and Desmos will provide you with the 5-number summary. The 5-number summary is necessary for making things like box plots. Desmos will also calculate standard deviation. It has an abbreviation. Standard deviation, again, in parentheses, I put L, and here's our standard deviation. One more thing I want to show you that you might want to make students aware of is students can actually, from their list, create some visual displays. By that, I mean they can create a dot plot. Now, dot plot is normally 2 words. Desmos squeezes it into 1. I'm going to create a dot plot for list L. There's my dot plot. If I don't want a dot plot, I can create a histogram. The students have to spell histogram, all lowercase. Here's a histogram for list L. And the last display that's also nice for them to have is a box plot. Again, normally 2 words. We have to use 1-word commands with Desmos. So there's your box plot based on list L. So these are some nice, convenient things that students can do if they're using this Desmos calculator. One more thing I want to show you before we jump into the activity side of the platform, and that is, I'm going to delete my list here, or my everything. Let's see, delete, there we go. I want to show you how to create polygons, because polygons, again, are great for visualization. So there are several ways that we can create polygons. I can do them from a table. So I'm going to add a quick table here. And let's put a point at 0, 0, another one at 4, 2, 4, 4, and 1, 2. I guess I could make this look a little, yeah, let me change it from 1, 2 to 0, 2. There we go. So I just have a series of 4 points there. But I can also create a polygon around those 4 points by using the word polygon. Again, all lowercase, and in parentheses, what am I going to reference for my polygon? Well, my values in the table all have x coordinates of x sub 1 and y coordinates of y sub 1. So I just simply type those, x sub 1, and I just type a 1 after the x, and Desmos knows you want a subscript, comma, y sub 1, and it creates a polygon around those points. And that polygon, again, I can style it how I'd like it to look. So I'm going to press down and hold. I can make my polygon blue, orange, whatever color I'd like. I can make my line around it, my perimeter of that, thicker, if you will. You can have your perimeter be dashed. You can have the fill be darker. I mean, these are all different things you can do with creating that polygon. So that's just a quick introduction to the Desmos graphing calculator. I've checked. I don't see any questions in the chat. So can I answer anything for anyone before we move forward? Okay, I'm going to interpret silence as no questions, so feel free to interrupt if you do have questions. I'm adding to the chat here a link if you could click on that link I just put in the chat, Thank you, Dr. Alexander. Yeah, add your questions to the chat or just hop on the mic. But I added a link in the chat for an activity. So I think the best way for teachers to get introduced to Desmos activities is to experience them as a student would. So I'd like you to click on that link, please. And after clicking on that link, you'll be taken to a certain screen. Now, the screen you're taken to is screen 6, and I see 2 of you there right now. On my shared screen, I'm looking at the teacher dashboard, the teacher summary. So in this scenario, I'm the teacher and you're the students, and I see 2 of you have joined, Lydia and Dee, and I'm just going to wait here for the others of you to join as well. Feel free to click Start Activity, and you will also be taken to that same screen number 6. So I see Kimberly and Veronica are coming in now. Now what we're going to do, as we're waiting for a couple more people to come in, the screen you're on, we're going to go through a possible depicted lesson, a short abbreviated lesson that comes from illustrative math using its math curriculum. So I imagine most of you do not use illustrative. That doesn't matter. This one is about linear relationships and linear proportions, and any curriculum out there will have those particular topics. So what we're going to do is go through some things together, and you can experience some of these activity features. So I'm going to open up the next screen for you, and that's screen number 7. I'd like you to go to screen number 7. And on screen number 7, the equation y equals 4x can represent several different situations. I'd like you to think of a possible situation and write a description of it. What can we model with y equals 4x? Please describe what your quantities x and y would represent. So let me give you about a minute here to type that in that box on screen number 7. And it's Saturday, and if you're having a little trouble getting started, like I'm not sure what to do with y equals 4x, I'll give you a one-word hint. Starbucks. Can you use something with Starbucks? Okay, I'd like to ask you now to go to screen number 8. I've opened up screen number 8 available to you. And what we're going to do now is, after you as a student have come up with a possible scenario to represent with y equals 4x, we want to see if we can go about justifying some of the math behind it. So there's a table on screen number 8, an x and y table. So I'd like to invite you to fill in some x values and corresponding y values. I'm suggesting you use x values between 0 and 4. So for example, where my cursor is now on my shared screen, if I type in 0, I can arrow down, I can add in other values. And then you can fill in the corresponding y values based on them fitting into the equation y equals 4x. So I'll let you do that for a moment. And what you will see as you're filling in your table, once you have a valid x coordinate and a valid y coordinate next to it, Desmos can plot those for you. So it's nice to give students a visual representation of what the table represent. And you'll see plotted points appearing on the right in the graph. And students will be able to look at those, and visually it will be easier for them to see a linear relationship there than if they're just looking at the table. Although both are important, it's a great connective piece to have multiple representations available for students. Okay, I'm going to open up screen number 9. If you could go to screen number 9, please, when you're done with your table. And the next thing I'd like to ask the students to do, is to make a graph to represent y equals 4x. So in box number 2, and this is basically a graphing calculator inserted into the activity, type in y equals 4x. And your points from your table carried over from the previous screen. That's another feature of computation layer. It allows different components on different screens to talk to one another and to interact. And so what we have here is an excellent visual representation. I'm going to click on Veronica's screen for a moment. And Veronica has points here illustrated by these blue points, and her line y equals 4x hits them perfectly. So this is, again, a nice connective piece for students to have. Okay, we're going to skip screen 10. Normally, if this is an in-person webinar or in-person workshop, we would do some sharing. We're going to go ahead and go to screen 11. And on screen 11, we're going to do some comparison work, which is really important in mathematics. Elena babysits, and her earnings are represented by the equation y equals 8.40x. Jada mows lawns, and she earns $7 an hour mowing lawns. Who do you think is going to make more money after working 17 hours? I'd like you to just be a student here and just give me a one-word prediction. Do you think Elena makes more or Jada? Just type in Elena or Jada if you're participating with this. And if you're just following along visually, just think about that a little bit. Who do you think would make more money? Now, after having students make a prediction like this, I'm sure we're all thinking on the same page here. What comes next? Well, as math teachers, we want to have our students justify or defend their prediction. And that can happen in a sequence of screens following. Let's go to screen 12. Again, we can have the use of a table to help justify. So for 14 hours worked, if you take 14 and substitute it in for x in Elena's equation, you'll get the amount of money she earns. And you have to figure out, what do you want to do with 14 and Jada's $7 per hour? Well, these are getting into some numbers that are bigger, and students are going to need calculators here. There's a built-in calculator. I've added a calculator feature here, and I'm hovering on it on my shared screen. You can click on this, and a scientific calculator opens right here. So you, as students, can access this and start to fill these table values in. But I also want to show you another feature in a table. A Desmos table also evaluates for you. So in my shared screen here, I've selected the first box under Elena, and I can type in things like 8.40 and put 14 in parentheses, and Desmos will evaluate it for me, just like it would if it was a graphing calculator. So these are nice for students to have the tables evaluate for them. And so, like most other things that are digital, copy and paste works. So I selected my 8.40 times 14, and I can copy it with, there we go, Control C, and paste it with Control V right below, and change my number of hours. And paste it in below again and change my number of hours. So students will pretty quickly learn how to be efficient with this calculator to evaluate when they can use copy and paste. So besides justifying a comparison between Elena and Jada with a table, we can also do that with a graph. Go to screen 13, please. Screen 13 asks you, the students, to enter an equation in box number 2 to represent Elena's earnings, and another equation in box number 4 to represent Jada's earnings. So let me go ahead and have you do that right now, please. If you have to refer back a screen or two to get what those earnings are, you have that ability to do that as a student. Now, in looking at some of the graphs here, I'm going to click on Lydia's graph for a moment. And as a teacher, you have the ability to access any of your student screens that you want to look at. So I clicked on Lydia's graph. And one nice feature about Desmos graphs that we saw earlier is when you graph two different things, they come in different colors. And so here's another nice visualizing piece that the blue equation, which is Elena's earnings, has a steeper line than the red. And so what you can do is you can have discussions with your students and ask them to put more formal terms to this. And eventually you might want to have them talking about rates or rate of change or slopes, things like that. But again, you can provide them the visualization by using two simultaneous graphs here. And here's another nice feature I didn't show you before. When you have things graphed, is you can click on any one graph with your cursor, and there's a graph trace feature. So I clicked on this blue graph and I see an ordered pair showing 12.76, 107.184. That's the X and Y coordinates of the point I'm at, but I can drag this along the line. So I can use my trace feature to find specific values. So if I want to drag this to an X coordinate of 17, I can get really close. There it is, exactly. So you can have some discussion with students about what's the meaning of 17, 142.8. Well, that means after Elena works 17 hours, she earns $142.80. I can let go of my cursor and the trace disappears, and I can do the same with Jada's graph. And I can drag this. Let's see if I can get the trace to be at 17 hours. It's sometimes tough to get it right on the money. There it is. After 17 hours, Jada earns $119. So not quite as much as Elena. But again, you're giving the kids the opportunity to explore things visually and see the mathematics and not just memorize the theoretical part of it. And for those of you that really want to engage your kids, teach them how to do this type of stuff. In box number 5, you can type in x equals 17. A third line is created. I don't like that it's red, so I'm going to make it green. And now we have intersecting points that we just saw with the trace feature. But with an intersecting points, we can get them now to stay permanently. So Lydia, I've kind of butchered your graph up there. I apologize for that. Let's go ahead and go to screen 14. Now, after having those discussions with kids about what those visual representations were, then you can maybe ask them, what is the rate of change? Try to put it in your own words. Can you describe what it means to you, a rate of change? Well, with all of us being math teachers here, I'm not going to ask you to do that right now. I'm just saying that would be a good logical extension to come after the screens we just saw. So instead, I'm going to have us go to screen 15. And here we can give students a choice. Use your table on slide 12 or use your graph on slide 13. Determine how long it's going to take each of those girls to earn $150. Try it out. I love giving kids options to do something with their own desired strategy. So I'm just going to pause here. And again, if you have any questions, put them in the chat, hop on the mic, whatever's comfortable for you. Okay, I saw some great work. Kimberly, I want to highlight your work here. I'm going to click on your graph. Kimberly chose to use her graph. And what she did to make her job more efficient as a student is she created a third equation here, y equals 150. Since we're looking for how long it's going to take to earn $150, she now has a horizontal line going through 150. and that creates intersecting points. So she could click on these points. They both share a y coordinate of 150, but it gives you the x coordinates, which is the number of hours necessary to earn $150. So the blue line has an x coordinate of 17.857. It's going to take Elena just under 18 hours to earn that much money. And it's going to take Jada about 21 and a half hours. So again, you can get some nice visualizations with students. Kimberly, I love this strategy you used here. Great stuff to teach kids. Let's go to screen 16. Screen 16, we're going to do some pattern finding here. Claire and Han have that old math problem, summer job, stuffing envelopes. Han can stuff 20 envelopes in a minute, and Claire can stuff 10 envelopes in a minute. So together, working together, they can stuff 30 envelopes in a minute. They start working together on a pile of 900 envelopes. See if you can use the graph to figure out how long it's going to take them to finish the pile. Right now, where your cursor is located, 8,240, that means it will take them 8 minutes to stuff 240 envelopes. Well, can you just drag it all the way until you get to a y coordinate of 900? Try it out. And at this point, usually, if I were running this with students, I'd have several kids in the back yelling out, "Your graph's broke," because it stops right here. Well, that's on purpose. I restricted this graph to only go to this point here so that students could use it to find a pattern, but I didn't want to make it super easy on them. So see if you can figure out how long it will take them to finish the pile and press the submit button. You just need to type in the number. Minutes will appear automatically at the end. And once you press the submit button, you'll also see something else occur. You'll see feedback generated for the students. The feedback appears in this space right here. So if you haven't already determined 30 is the correct number of minutes in order for them to stuff 900 envelopes. Watch what happens in this space when I press submit. There's a little short piece of feedback. It can include text and or emojis. So the students get this piece of feedback instantaneously based upon their answer. Well, you're probably wondering, what if they didn't type in the correct answer? Let me change my correct answer, or my answer, to 3 and press submit. Then they get a different piece of feedback. And that feedback can be put together and determined by you, but it involves computation layer. So I'm just showing you an example of something that computation layer can do. If you want to learn more about this Desmos platform down the road, it can be used to provide student feedback. So I'm going to go ahead and put 30 back in and press submit. In addition to the feedback, it also opens up a follow-up question. When they're all done, how many more envelopes has Han stuffed than Claire? Try that one out. This is a follow-up question that is remaining hidden until the students correctly answer the first part. That's also an example of computation layer in play. Now, we won't be exploring any computation layer today. This is just mainly an introductory webinar, but if you're interested in learning more about it, there are some options available to you. Okay, I want to move us along. I'm conscious of time here, and I want to make sure you get to explore some of the things I wanted to have you explore. Go to screen 17, please. Screen 17 is a great way to conclude a lesson. It's a great way to have an exit ticket. some sort of formative assessment to check your students' understanding. It's called a card sort. Basically, what we're going to do is drag cards together that represent the same relationship. So I'm going to make my shared screen go full screen so that you'll be able to see it easier, and I'll show you how to get started with it. Each of these things you see are movable cards. So I'm dragging this table and just kind of swirling it around. Here's a graph, and here's an equation. Here are the directions. I want you to make 3 groups, each group having a graph, an equation, and a table that represent the same relationship. And right now, I have at least 1 card incorrect. Well, they're all incorrect. I haven't grouped any yet. But let's go ahead and get started. I want to take you through an intro here and show you how you might do this. So I'm going to start with this first card in the upper left. Now mine says 1/2 x, y equals 1/2 x. That's an equation. I want to match that with my tables. So I have 3 tables here. And one of those tables should match that equation. So if we look at the x and y coordinates here, we want to pick out which one of these has a y coordinate that's half of what the x coordinate is. Well, that's going to be this second table. If you want to see the values a little larger, you can click on the table and it enlarges a little bit. It's not a lot, but it's a little bit. So if I want to pair together these 2 cards, I drag one of them to the other until they overlap, and you'll see a burgundy color. Let me show you what I'm referring to. I'm going to drag this table towards the equation, and when it overlaps enough, you'll see some burgundy color, purplish color around one of them. I can let go, and these 2 are grouped together, and I can move them around as they're grouped together. So right now I've grouped together an equation and a table, but I still need a graph. Well, the graphs are a little tougher to see, so I like to click on them to open them up a little bit. And it's tough to tell with my axes numbers what my slope is going to be here. So here's where I can use my graph trace feature. I'll click on this line, and here I've got an x coordinate of a little over 1 and a y coordinate of 8. Let's see if I can get it to exactly 1. It's tough to do to get it to exactly 1. There it is, 1, 8. So I don't want this graph to go with this relationship. I want this one to go here. So I'm going to drag this graph over until I get color to overlap, and now these 3 are connected. I can hide them or collapse them or expand them if I want to work with them. Now, Kimberly has a great question. If students make a mistake, how do they unpair? They can unpair them by just dragging one of the bottom ones away from the group. I can't grab the top one and drag it away because it controls the whole group. But if I want to pull the graph out, I'm just dragging it away. If I want to pull the table out, I just drag it away. And if I want to put them back, I overlap until I see color, and I overlap until I see color. So I'm going to collapse these, and I'm going to invite the rest of you to group together. Make 2 more groups of 3, please. We'll just do this very quickly here. And watch your feedback change when you get them correct. Now, Kimberly and Veronica have them all correct. Did you notice what changes here? You should see a different message. I believe it's got some little check marks on it. And on my shared screen, I'll go ahead and finish this out. And as I bring my last card in, watch this line right here. The feedback changes, and you get little check marks in there. Nice job. So a card sort is a wonderful way for kids to group together different representations. Here we have the algebraic equation, we have a graph, and we have a table. And it's a great way, again, to connect those multiple representations together. On screen 18, Desmos is constantly updating their platform and improving it, oftentimes taking suggestions from us math teachers. If you're interested in seeing some of the newest Desmos features, feel free to click on that link. It'll open a new page for you, and you can explore that at your leisure. Also, Desmos is committed to making sure that all of their activities, all of their mathematics, are as accessible as possible to students with disabilities. So they have all kinds of visual and auditory suggestions for kids that have those impairments. Again, here's another link that will open in another page. Feel free to explore that at your leisure. Okay, I'm going to take us to screen 19. So you just experienced a part of an activity together as a student. Well, now I want you to put your teacher hat back on. And how do we find activities that we want to use for our students? There are two main ways to do so. We can use the Desmos search engine. I'll show you that momentarily. And we can do a plain old Google search, a browser search. And things that we find, we can use. All Desmos activities you find, as long as they're not part of their paid curriculum, are accessible for you to use free with your students. So let me show you how to use the Desmos search engine first. I'm going to open a brand new tab. And my brand new tab, I'm in Google Chrome, but this works on any internet browser. I'm going to go to a different part of the platform that we were at earlier. Where we were earlier was desmos.com. I'm going to go to teacher.desmos.com. This is the teacher side of the platform. And when you're in the teacher side of the platform, if your name does not appear in the upper right corner, this side of the platform uses first and last name, you'll be prompted to sign in or log in or create an account. I encourage you again to do that because any activities you want to use, save, edit, create, all of that stuff can be organized and saved by you. So I just want to show you briefly how to search for activities. There's a little search engine near the upper left. I've just clicked my cursor into that, and you can type in keywords, things you want to look for. So maybe I want to look for something that would be, I'm going to pick quadratic. As I start typing quadratic, I don't even need to finish the word. Desmos will auto-recognize I'm looking for things that start with those letters, and it will provide for me quadratic functions. This is a collection. A collection is simply a folder full of like-themed activities, and then you'll see some different activities listed below. But if you want to see more than just this, keep typing the word quadratic. I'm going to make it quadratic functions, and I'll press enter. Here's that collection. So you can open this and see all kinds of different activities available dealing with quadratics. If you want to see basic activities, you can just scroll down, and here are 7 different functions that represent quadratic activities. If you want to look at any of those functions, you can simply click on the activities. So I'm going to click on this last one by Bob Lachelle, who's a math teacher in Philadelphia area. He's a great math teacher, Desmos expert. I'm going to click on one of his activities because he usually has good stuff. So you'll see some information about this activity. In fact, this is an activity that I liked and I grabbed to use it myself. I made some minor changes in it. But you will see screens in this activity. It's a fairly short activity. And you can click on any of these individual screens and see a full view of them. And you can navigate through this activity as a student would. And if you decide you like this activity, I'm going to go out of preview mode now. you have the ability to assign it to your students. And that's what we're going to do in our last session here in just a moment. Talk to you about how to apply activities to your classrooms and some teacher tools. So I'm going to show you that in just a moment. But this activity is available for you to use if you want to have access to it. You can't change it unless you create your own copy and edit. And again, that's outside of the scope of this webinar. If you don't like what you find in the Desmos search engine, just do a plain old Google search. So I'm going to close this screen out and open up a new tab. And I'm just going to flat out type in what I'm looking for, but I want to put a couple of keywords in. I want to use Desmos activity. Otherwise, I'll get stuff that's unrelated to Desmos. So I typed in Desmos activity, and I'm going to search for maybe ellipses, because Desmos doesn't have many ellipse activities in their search engine. So I'm going to type in Desmos activity ellipse. I'll press enter, and I'll see a whole list of activities. All of them have a URL starting with teacher.desmos.com. And you can click on any of these that you want to look at and see what you think. This is a good one. I recognize Stacy Bender as a good author of Desmos activities. And as you get into this, you'll start to recognize people as well. And you can take a look going through Stacy's activity. Hers is a little longer. This one's 14 screens. You can click Student Preview and go through the screens as students would and try it out. And if you like it, you can assign it to your students as an activity in your classrooms. Now, I'm going to eliminate that screen, and I'm going to take you back to the Desmos activity we were working on. And I'd like to ask you to add to the chat something you maybe just have experienced just now that you'd like to use in your class. Have you seen anything thus far that you could see yourself using with your students? I'd love to see some of those shared in the chat. So I'd like to pause for a minute or so to have you type those in the chat, please. Okay, Dee added in the chat that she could see herself using some tables and sorting the tables and creating polygons. Awesome. Great visual opportunities for kids there. Okay, Lydia is pretty new to Desmos, and she'd love to use some activities in class. Visuals are really useful. I completely agree with everything you said there. So when you get some time, Lydia, if you just want to search for activities that pertain to you and your students, there's thousands of them out there. And Kimberly, yes, the stats. I love the stats feature of the graphing calculator. We just have to make kids aware of those things. So I'm glad you're excited to do that with your students, and also the connections between the various representations. All kids don't learn the same way. So if we can reach them where they best see things, that's awesome. Oh, Stephanie, pre-K. This is awesome. Most of the work I do with teacher training involves secondary, but there's a growing population of elementary teachers. There are some really cool elementary things that you can do to help kids build number sense, to visualize some of those elementary concepts. So at the end of today, I'm going to share my contact information. If you want to reach out, I'd love to take you in a different direction than where we are right now, because this is a little bit beyond where you're at with pre-K. But reach out later, and I can show you some different activities that you can employ. All right, we're gonna shift gears here a little bit, and we're gonna go into our last session where we're going to step away from student perspective and more into the teacher perspective, and how do we assign activities for our students, and how do we monitor them, and what are some of the teaching tools that we can employ to make sure that our kids are engaged in the classroom. So what I'm going to do is I'm going to open a new tab here, and as this webinar goes on, I'm probably a lot like you, I'm getting more and more tabs open across my screen. I'm going to go to teacher.desmos.com again, the home page for the activity part of this platform. We were just here a few minutes ago. And there are lots of things to explore here on the left-hand side. We're not going to have the time to do all of that. But I do want to point out things that we can do. And if you're going to be a teacher that wants to do several Desmos activities or more in the course of a year, I'm going to encourage you to create a class. By creating a class, you can assign activities to multiple classes if you're at the secondary level, and it just makes it a little bit more efficient for you to get the activities from you to your students. So I'm going to click on classes right now. Under manage your classes, this is probably for most of you anyway, your secondary perspective, so you probably teach more than one section of math. These are my classes. Now my classes are unreasonable. Every time I do a teacher workshop or training, I create a new class. So you won't see all these different classes here. If you're a middle school teacher or a high school teacher, you might teach 2, 3, 4, up to 6 sections of a class. What we're going to do is assign them to classes, the activities, and I want to show you how to create those. So if you are interested in doing this, watch as I take you through this process. I'm going to start with add a new class. So when you add a class of students, you have a couple of ways to do so. If any of you are Google Classroom users, you can import directly your classroom rosters from Classroom, and they come right in, and it will coincide nicely with Google Classroom. If you're not, no worries, you just have to create a class name. So I'm going to create a name here. I'm just going to call this Saturday, October 14th for today because I have so many classes. So this is our class name, and I'm going to add this class. And it will appear in my list of classes alphabetically. Now I have to go all the way down to the S's because I called it Saturday, October 14th. And right now there are 0 students in here. And I want to show you how you can bring students into this class if you're not using Google Classroom. I'm going to click on this join code. And here's what I'm going to ask you to do. You're going to go to student.desmos.com and you're going to type in that join code. Student.desmos.com, you're going to type in that join code. You can also send this link to students via email or other message application. I'm going to put it in the chat. So whether you want to go to student.desmos.com and type in that join code or click on this link that I just put in the chat, the link in the chat includes the join code in it. And what I will see then is a list of students that have joined. Now I see Lydia has joined. And I'm going to wait. There's Veronica. I think we have a couple more I'm going to wait on. And you have the ability as a teacher to approve or deny each student. I don't really think there's a scenario in which you want to deny a student unless some kid that's not in your class wants to join, but I think that's a pretty rare scenario. There we go. There's 4. I can just click approve all, and all 4 of you are now part of this class. And here's the nice thing, when you have students in a class, you only have to do this one time, or maybe if you switch students at the semester, you have to do it twice a year, but this is usually a very infrequent type of thing you have to do. Now your class is set up and you can assign them activities. Let me show you how to do that. I already have an activity open that I want to assign to my students, which is you. So I clicked on another tab here. And this is a session. This is a session I've done multiple times over the previous months with different groups. I can go right to my assign button, and I have 2 options. I can assign it to my classes, or I can create a single session code and share that code with students. But since you created your classes already, I'm going to assign it to a class. So I'm going to click assign to classes. And I can't assign it to all of these here that are kind of faded out because I've already done that with those groups. But if I scroll down to where Saturday, October 14th is, this is our class and you haven't done this yet. I can check this box and click assign. And you will now see it in your student.desmos.com activity. So go back to student.desmos.com and you will see this activity created for you. It's called Desmos Classroom Strategies, Running Activities. I'm going to click on my dashboard so I can see who's joined this activity. And I can see Lydia is in and Veronica is in, but Dee and Kimberly haven't started yet. I'm not trying to embarrass anyone. I'm just showing how you can look at the color and the font here to tell which students have joined your activity. Now, all 4 of you are in, so we're ready to go. So I'm going to start this out by talking about the screen you're looking at right now, my shared screen. My shared screen comes from this tab at the top. There are 4 little tabs here, and I'm on the summary screen. Most people in the Desmos community call it the dashboard, the teacher dashboard, and that's what I will refer to it as well. So on my dashboard, I can tell I have 4 of you here in this activity, and I can tell which screen each of you are on. I know it sounds a little intrusive, doesn't it? But I can tell Lydia's on screen 2 because this block is highlighted, and I can see Veronica and Dee are on screen 1, and Kimberly's moving ahead. She's up on screen 3 already. I can also hover and see names right here. So what I want to have you do here, and we're not going to have the time to explore all of this, I'm going to ask all of you to go to screen 3 for a moment. And screen 3 shows a screenshot of a previous activity that I ran with students. And this screenshot shows the teacher dashboard, or a portion of it. And what you will see here are different icons that represent what students have done. So I want to just touch on some of those briefly. As you would imagine, any screen that has a check below it means a correct response was entered by the student. Any screen that has an X indicating at least something was incorrect. And you will also occasionally see a dot. A dot just means it's not necessarily correct or incorrect, but it needs to be visually checked by you, the teacher. Examples of screens that would have dots would be questions where students are asked to explain things or justify something in words. Basically, responses that are open-ended cannot ever be checked by Desmos for correctness. But if you include slides that have things like multiple choice or card sorts or ordering, reordering lists, things like that, those are all things that Desmos can auto check for you. Some of it can be done easily and other parts of it need computation layer. And again, that's for a later part not covered today. Also in this screenshot here, you'll see dashes occasionally. The dashes just indicate that there's no opportunity for the student to respond at all. It's just something that they read. So in looking at this dashboard, if I'm running this activity right now with my students and I see all these checks, I'm feeling pretty good. I see 1X over here. I can, as the activity is still going on, I can wander back to see Jacqueline and say, maybe make a suggestion to her to try and improve upon that response there. But this is just an example of a teacher dashboard showing the different icons. Now, I'd like to invite all of you to go to screen number 5. And so when I said I'd like to invite all of you to go there, I'm going to force you to go to screen number 5. And what I did is turn on the pacing tool. If you do a quick look at my screen, my shared screen, screen number 5 is now boxed in orange. And all 4 of you are on screen number 5. You can pace students to where you want them to go. Now I can move my pacing with these arrows left. So I'm moving you all to screen 4, and I can move you back all to screen 5. So what I would like you to do is, since we're on screen 4, screen 5, I'd like you to do screen 5 as well as screen 6. So I'm going to stop the pacing and re-engage it to include screen 6 now. So I'd like you to just take 30 seconds or so and do screens 5 and 6. And I'm going to put on the teacher dashboard so we could take a look at results here. Now, if you're new to sliders, I'm going to jump over to screen 6, and I'll give you a little heads up on how to work with the sliders. We're trying to graph a couple of equations. I'm trying to highlight this. There we go. I'm trying to graph y equals 2x minus 4. And right now, the red equation is graphing y equals ax plus b, with a being 1 and b being 2. Well, I want my slope, or my linear coefficient, to not be 1. I want it to be 2. So I can move this to 2, and you'll see my line changes. And I want my y-intercept to be negative 4. So I can move this over to negative 4. So here you're asking students to manipulate variables here to create y equals 2x minus 4. And then you also want to create y equals negative x plus 14 using variables c and d for the blue equation. So go ahead and modify those a little bit. Now, as you're working, I'd also like you to take a peek at the shared screen. The shared screen is showing the teacher dashboard, and you can see some different icons available. You'll see a check mark here, you'll see some dots, and you'll see an X. Again, the check mark means the student was correct on that screen. The X means there's something incorrect on that screen. And the dot just means it needs to be visually checked by the teacher. You should also notice this purple bar here. That's because I've turned on the anonymize mode. And what the anonymize mode does is make all of these names here on the left become anonymous. These are famous mathematicians from history. So if I hover over a name quickly, this is Kimberly here, but she has a fake name right now. And I've turned on the anonymous mode with this button right here because anytime I display student work for other students to see, I never want them to be embarrassed. And so I try to make a practice of that with the teacher groups I work with, to not embarrass teachers, to feel like their work is going to be scrutinized if they're wrong. So I turned on the anonymized mode, and it allows students to feel a little bit safer about being wrong, because all of us at one point or another are wrong in math, and we can learn so much from mistakes. And I don't want kids to be scared of making mistakes. So time-wise, we're going to move forward here, even though we only have one correct check for screen 6. All of these on screen 5 are dots, most of them anyway, because there's an open-ended response question there. So if I want to allow students to go to screen 7, 8, 9, etc., I have to either stop my pacing, edit it, or here's the tool I like to use most. I use this little plus sign. I click on the plus sign and it opens up one more screen. So I can use it again and again. I just opened up 3 more screens. So I'd like you now to do screen 7 and 8 and 9, and I'll keep it on this dashboard here. And as you're going, I'm watching the dashboard and it changes in real time. So I can see what screen students are on, and I can also see a series. I'm getting some check marks coming in there. Now, as a teacher, if this is in the classroom, I'm not sitting behind my desk for the entire class period. I'm walking around and I'm making frequent laps around the room. And every 60 seconds or so, one of those laps will come back behind my desk and I just do a quick peek to see how students are doing. Those of you that might do this with handheld devices, that's great. Look at all those checks coming in, looking great. So what you're seeing in real time is how a teacher can monitor student progress as we go. So I just see the last 3 screens, everybody has checks. That's awesome. So I know I don't need to revisit that section of screens. I can go ahead and move us forward. So I'm going to move us over to screen 10. And I put screen 10 in here. And I'm going to have you all go with me to screen 10. So I'm going to show you another feature, Sync to Me. I press Sync to Me over here on the upper left, and all students are synced with the teacher screen. So I was on screen 10, so all of you go to screen 10. If I wanted to go back to screen 8, all of you will follow me back to screen 8, like it or not. It sometimes can be a little laggy. I can see one person still on screen 10. That's because they have a different tab open on their computer. That's what I've learned about there. But I'm going to ask you all to go back to screen 10. And I just put in here, I call this a COVID screen. Back a few years ago when we all had that time in March where we're all given 48 hours to get ready to teach virtually. So I started to put some things together for students, and I used a lot of Desmos activities during that time period. So this is just the substitution method. And if we have y equals something and y equals something else, we can set the something equal to the something else and solve it for x and try and get the ordered pair. So I'd like to ask you to go to screen 11 and see if you can solve this system by setting 2x plus 6 equal to negative 4x plus 12 and typing in the ordered pair answer. And just observe some of the feedback. Now you'll see a couple of different kinds of feedback. You'll see feedback that's visual on the graph, as well as some feedback in terms of text and emojis. So try to account for that as you go through. So we're giving students opportunities to make mistakes and modify or fix those mistakes. Again, in a very safe environment. And that feedback, I found, as silly as it may sound, that kids love to see images, kids love to see emojis, things like that. So whenever possible, if it's convenient enough, I try to include those types of things in my feedback as I'm creating activities. So if you're having a little trouble on screen 11, let me think how I want to phrase this. You need an ordered pair. An ordered pair. I'll give you a little hint. Your x value should be 1. See if you can find the corresponding y value that goes with 1, and then press submit. And see how that screen interacts feedback-wise. So on screen number 11, x should be 1, but you need a y coordinate with it, and it needs to be in an ordered pair format. Parentheses, x comma y parentheses. So again, if you're having trouble, just try the ordered pair 1 comma 8. Type in parentheses 1 comma 8 on screen 11. Put parentheses around 1 comma 8. You have to have parentheses, left parentheses 1 comma 8 right parentheses. There we go. Perfect. Now, one other teacher strategy or tool to talk to you about, show you, and I want you to experience this, is the pause button. So I just press the pause button. And if you're like most students, you get annoyed with that. So some of you are feeling very annoyed right now that you got interrupted in what you're doing. The pause button freezes everybody's screen, and it's a great way for you, the teacher, to make sure that the students can hear what you're saying to them. And I want you to also think about this. Take it as a compliment. When's the last time your students were annoyed with you for interrupting their math work? So take that as a compliment that they're engaged in the activity as they go. I'm going to press the pause button again to take it off, and now you can continue. But before we can finish screens 12 and 13, I do want to show you a couple other things. So I'm going to ask you to go to screen 14, and I'm going to put on sync with me to kind of force you all to go to screen 14. What if you don't have a graph to visualize the result of your response? Can you tell how many solutions a linear system has just by seeing the equations? Try it out. Type in a response. And again, I have the anonymized mode on, so I don't want any of you to feel embarrassed over your response. Okay, looks like we're just going to have one response here, so I'm going to turn off the anonymize feature. Oh, thank you, Lydia. Go ahead and keep typing, Lydia. Here's what I want to show you all. There's an option with different screens to grab students' work to use it for other purposes. So Kimberly here has a box next to her name. And Lydia, if you could just go ahead and click back in your box again, even if you don't type anything in there, just type a single word, that'd be great. Perfect. I can select Kimberly by putting a check here, and her response comes over here. This is called a snapshot. I could also select Lydia's, and hers comes over here. And we can create presentations with this. So this is completely anonymous, but this is something that can be dragged over to a smartboard or a projector screen. And I love to use the snapshot feature to have students peer critique and peer review. And so I might say something to students like, here are two of your responses. Are they both correct? Are they both incorrect? Or is one correct and one not, and why? Talk to your partner, and I'll give you 20 seconds with it. So I'll make the students talk about their own responses. And sometimes you have to teach the kids to do it in an appropriate manner and not use inappropriate words and things like that. But this is a great opportunity to have kids talking about math using these snapshots. You could also type your question in here. I usually just give it to them verbally. It's quicker for me. I can save this by clicking Save Album. And then when I'm done, here's my Snapshots tab up here. And it contains the number 2. I have 2 different things in my snapshots. So now in my snapshots and my summary, these are different views the teacher has. The teacher can also click on the teacher tab and see individual responses for any screen. And you can also see the student view on any screen. So there's great different options here for viewing. I'm going to go back to the teacher tab for a minute. I can also choose to send feedback to students that are selected if I don't want to have students talk about their work. So right now I have 2 students selected. That's all that's on this screen, so I can't really send it to 3 of you. But I can send feedback in terms of a written response. I'm just going to put great job, and I'm going to press send. Now before I press send, I want you to watch up here, see if you can notice visually a cue that feedback was sent. Do you see the little green half triangle in the upper left? Lydia has read her feedback because her triangle went from green to gray. Kimberly, see if you can access where feedback is. It looks like a little text notation. There, Kimberly's read hers. So I can send one-way feedback from teacher to student, but it's only one way. And the student can't respond and I can't get conversations going. This is just a quick way to send one-time feedback. And again, just because students open it doesn't mean they digest what you're sending them. I used to type these long, expansive responses and students would just click on it and not even read half of it. So just consider what it's there for. So that's the feedback option. Okay, we're kind of getting real low on time here, and I'd like to wrap things up here and turn it back over to Desiree. I want to first ask if there are any questions before I do my final wrap up here. And again, type those in the chat or turn your mic on and ask away. Okay, I'm adding something to the chat. It's again my presentation link. You saw it earlier. It's this document. And the reason I want to highlight that again is it has contact information for me along with some other resources for you as math teachers. First of all, if you have questions on anything, we just had a 2-hour webinar here. Normally the workshop trainings I do for teachers are more expansive. They're normally 5 to 6 hour workshops. So I realize we didn't get into some things that you might have questions on. Send me an email, please. This is what I do now. I'm no longer in the classroom. I do consulting work, and 90% of what I do is teacher training, something related to Desmos. So I'd love to help you out. If any of you want to explore more with Desmos, I have a YouTube channel. My link is there for that. If any of you want to connect on social media, my different connections are available on this page. And I also want to give you some other links. On the left here, it says links to my collection. This will take you to a later slide. And here are my collections. These are all mainly high school related. But if you're interested in checking out any of the activities I have in those, grab anything you'd like. They're free to you to use. Grab anything you'd like to use. Some things we didn't get to today that I would have liked to if there would have been time. Desmos has a new geometry tool that's out. A great way for kids to visualize in front of them geometric transformations, things like that. Desmos also has a 3D calculator out now, brand new as of like less than 2 weeks ago. Again, a great visualization tool for solids in geometry. So there's some really exciting things coming down the road. And I would encourage any of you math teachers that want to explore more, there's tons of stuff available. And so again, if I can be of any service to you, please reach out to me. I do teacher trainings. I do in-person ones and virtual. So if any of you are interested in me coming to your school or to your local RISA or whatever your organization is that provides teacher training, I do 1 and 2 day workshops. I can do any of those things. So please feel free to reach out to me and we can connect further on that. We have a question in the chat about reflections on Desmos. Kimberly, can you elaborate on what you're looking for?
Okay. I also teach high school geometry, and I was playing around with Desmos, and I could not figure out how to do a lot of reflection.
Okay. Desiree, do I have 1 minute or should I end it?
You can absolutely answer.
Okay. On my shared screen, I'm going to pop into desmos.com again, where we were earlier. There's a geometry tab here. I'm going to just show you very quickly. This is super quick. I can grab, or I can click on this tool right here, and I can make polygons. I'm going to make a 4-sided figure. I can then add a line segment anywhere I want it to go. And then I can choose to select this polygon and transform it. reflecting over a line, and there's the transformed polygon. And what I can do is that transformed polygon, I can change its color. And now here's the nice piece. If the original changes, so does the reflection. If the reflecting line changes, so does the reflection. So these are some tools available in the Desmos geometry tool. I know that's not enough to get you going, but I have several videos on it if you want to check out my YouTube channel that'll take you into a little more detail and get you going. So Kimberly, I hope that answered what you're looking for. And before I sign off and turn it back over to Desiree, I just want a quick message to all of you. I want to compliment you and acknowledge you for what you do. Not just spending time on your Saturday here, but every day in the classroom. It's I feel very fortunate to have spent a couple of hours with you. It's really tough nowadays to be a teacher. It seems like teachers get dumped on from every direction in every possible manner, and it's really hard to deal with some of that stuff. And although your students may not appreciate you, or they may not show it, they do appreciate you. And I know your parents appreciate you and your administrators, and well, I appreciate you too. And so I want to say thank you for the opportunity to spend this time with you. And if I can ever help with anything, please reach out. So thank you, everyone. Desiree?
Thank you so much. That was such an amazing, amazing, amazing webinar. It was so informative. Everyone, make sure that the recording will be there for you to look back and see everything. Andy, thank you so much. And hopefully we can have you back.
My pleasure. I'd love to come back anytime.